Hi everyone, presented to you are the objectives that we will meet at the end of this instructional video. We will have first a brief review to be followed by an in-depth discussion with examples. Then lastly, you'll wrap it up with a short exercise to check for understanding. Alright, we are all set. Let's start. For our quick review, let us familiarize ourselves once again on GCF and division of polynomials. These are important skills to get us started as we discuss the concept of factoring. I provided problems with solutions and answers for your reference. Remember that you may pause the video should you need more time on this part. If not, then let's proceed. For our first example, let us factor 8x squared plus 4x. Our initial step is to identify the common monomial factor. We can do this by getting the GCF of the numerical terms and the common variable with the smallest exponent. To solve for GCF, we look at the given, and we have 8 and 4. Therefore, our GCF is equal to 4. For the common variable, we check what is present on all terms, and that is variable x. Checking on it, the smallest variable is x itself. We combine the answers, and our common monomial factor is equal to 4x. The second step will be to divide the common monomial factor with the given. We work on it by regrouping, and we simplify like terms accordingly. Our quotient is equal to 2x plus 1. For our last step, we combine by multiplying the common monomial factor and the quotient derived. Our final answer is the product of 4x and 2x plus 1. And we are done with the first. Let us try another one. For our next example, we are given 12a to the fifth b to the fifth minus 24a cubed b cubed plus 6a squared c squared. Following what we have in our previous example, we identify the common monomial factor by solving the GCF and common variable. For the GCF, we have 12, 24, and 6. Therefore, our GCF is equal to 6. Then, for the common variable, upon close inspection, you will observe that the variable a is the only variable present in all terms. Therefore, we will only work on variable a. Got it? And our smallest exponent is a squared. Combining the answers, our common monomial factor is equal to 6a squared. The second step will be to divide the common monomial factor with the given. We work on it by regrouping, and then we simplify like terms accordingly. Our quotient is equal to 2a cubed b to the fifth minus 4a b cubed plus c squared. For our last step, we combine by multiplying the common monomial factor and the quotient derived. Our final answer is the product of 6a squared and 2a cubed b to the fifth minus 4ab cubed plus c squared. And we are done with our examples. Let's proceed now with difference of two squares. For our quick review, let us recall squares and square roots of numbers. To square a term, we simply multiply the numbers by itself and follow the law of exponents for variables. For the square root, it means the opposite of squaring a number. Here we ask ourselves, what number can multiply by itself to give the number under the radical? Finding the square root of perfect squares is relatively easy. However, we need to understand that we might also find ourselves solving for numbers with imperfect squares. Let's proceed. At some point, you'll be requested to factor expressions by identifying special patterns. The difference of two squares is one of the most common. The good thing is, this type is very easy to distinguish. Whenever you have a binomial with each term being squared, or having an exponent of 2, and they have subtraction as the middle sign, you are guaranteed to have the case of difference of two squares. This would be our steps in solving it. Number 1. We find the square roots of the two terms that are perfect squares. Number 2. We write the factorization as the sum and difference of the square roots. Or you may simply follow this pattern. The product of a plus b and a minus b. Alright, now let's try to solve problems like this. Let's have our first example. 9x squared minus 49r squared. We follow these procedures to factor the given expression. Number 1. Find the square roots of the two terms that are perfect squares. We get the square root of 9x squared, and that's equal to 3x. Then, for 49r squared, that is equal to 7r. Number 2. Write the factorization as the sum and difference of the square roots. Following our pattern, the product of a plus b and a minus b, our final answer is the product of 3x plus 7r and 3x minus 7r. Let's try another one. For our second example, we are given e squared minus 121s squared. We follow again the steps in factoring. First, we get the square root of e squared, and that's equal to e. Then, for 121s squared, that is equal to 11s. After getting the square roots, we now express it as factors of the sum and difference of the square roots. And our final answer is the product of e plus 11s and e minus 11s. You're doing good. I assure you that. Now let's try another example. For our third example, we factor x to the fourth minus 81. We get the square root of x to the fourth, and that is equal to x squared. Then for 81, that is equal to 9. After getting the square roots, we now express it as factors of the sum and difference of the square roots. And our answer is the product of x squared plus 9 and x squared minus 9. Now, question. Is this our final answer? Please take note of the second factor, x squared minus 9. It is still factorable under difference of two squares. If we factor it, it is equal to the product of x plus 3 and x minus 3. Then we affix the first factor, x squared plus 9. Our final answer now is the product of x squared plus 9, x plus 3, and x minus 3. Got it? Remember that you may pause or rewind the video to get a better grasp of the competency. Now let's proceed to the factoring of sum and difference of two cubes. For this part, let us try to complete the multiplication process of the given. You may pause the video while you work on it. Now, let's check your answers. Did you get the same results? For our next topic, we will reverse this process. The products that we have are called sum and difference of two cubes. We will be factoring them to come up with a given multiplication statement on top. Don't worry, I will be here assisting you. Let's go! Just like the factoring method on difference of two squares, we will be applying the same analogy in solving for the factors. For the sum of cubes, we first get the cube roots of the two terms. Then we follow the indicated pattern. The same process applies for the difference of two cubes, only that the pattern is different. Now, if you are going to observe, you would see their main difference. Alright? And that is the location of the addition and subtraction sign. Got it? Now let's work on some example. For our first example, we have r cubed plus 125. To factor it, we first get the cube roots of the two terms, after which we follow the pattern indicated on top. We have the product of r plus 5 and r squared minus r times 5 plus 5 squared. We simplify it, and the final answer is the product of r plus 5 and r squared minus 5r plus 25. Just a reminder, we need to memorize the pattern so that it will be easier for us to solve problems like this. Let's try another one. For our next example, we have 64m cubed minus 216s cubed. Before proceeding, please take note that the general rule in factoring is that we always assess if the expression can be factored by a common monomial. In this way, the expression will become simpler and easier to process. Looking at our example, the coefficients 64 and 216 has a GCF of 8, so we factor it first. Then we proceed with the steps in factoring difference of two cubes. To factor it, we get the cube roots of the two terms, and we follow the pattern indicated on top. We have the product of 2m minus 3s and the square of 2m plus the product of 2m and 3s plus the square of 3s. Then we simplify, after which we have fixed 8 in the expression. The final answer is the product of 8 and 2m minus 3s and 4m squared plus 6ms plus 9s squared. Practice makes perfect, and by doing varied exercises in factoring, we will be able to master it. And I know that you can do it. Now, at this moment, let us work on some exercises to check for understanding. Let's do it! For our quick assessment, I want you to factor each item completely. You may pause the video for a while to give you ample time. Alright, good luck! Now, let's check your answers. Did you get the same results? Wow, great job! Congratulations! To wrap up our discussion, we need to understand the process of factoring polynomials, most especially in identifying patterns. I present to you the general strategy in factoring polynomials completely for your reference. So we keep on practicing to better improve our skills. Thank you for your active participation. I'm RJ Christopher Cruz, happy to be part of your learning. God bless.